From Nebraska and Iowa down to Oklahoma, Kansas, and Texas, this year's IBHS Hail Field deployment crisscrossed the Great Plains in search of hail-producing thunderstorms.
10 observation days out of about 15 in the field. That's a record for us.
Each day of the trip starts with an assessment of the day's forecast, where a storm target area is identified.
I also think probably see initiation down the dry line.
Teams get into position and wait. Then, as the storm approaches, the instrument deployment begins.
That's a high-stress, intense moment too, because you're jumping out of the van. You usually, as safe as you can, pulled off on the side of the road.
Each deployment consists of 3 teams, one that deploys an array of disdrometers and 2 teams that focus on shingle panel drops.
The panel teams, we can be pretty quick and pretty aggressive when it comes to storms because it's not going to take us that long to deploy. We need to deploy and move out of there.
After the instruments are deployed, teams retreat to safety, returning to retrieve the instruments and panels after the storm has passed.
Take those panels back to the lab, assess the damage on them, compare them with the kinetic energy that we got on the disdrometers, and see if we can correlate kinetic energy flux to damage severity.
Teams also collect and measure the hailstones in order to validate the instrument observations.
29.5, severe.
And perform a compressive strength test, crushing the hailstone to measure the amount of force needed to fracture it.
Ready to crush.
Yep.
Crushing.
Each storm the teams encounter in the field is different, some producing larger hailstones that will provide valuable information on which materials perform best in severe hail events and how many hailstorms the materials can survive, while others produce smaller stones in larger amounts.
Also captured one of my favorites, which is high concentration hail that covered the road in northwest Kansas.
This year, teams also had the chance to analyze some giant stones in order to catalog the structure of the ice.
So we were able to go 3D scan those in the hotel. We also took some cross sections of those hailstones to look at the internal ice structure.
All of the data collected on the trip is taken back to the IBHS Research Center, where it's pooled with data from previous trips to continue expanding knowledge on hailstorms.
It's a really cool experience to be able to actually see what you are trying to reproduce in the lab and seeing it in real life.
It's also used to help validate lab data on shingle products that have been tested at IBHS. And finally, IBHS will now be able to use the data to simulate real-world hail events inside the small hail lab and the test chamber during full-scale testing.
Everything we know about a hail event, its strength, the sizes, the concentrations, and actually run a building material through that exact case as best we can.